Hi, hello. This is Karthik. Today I'm gonna explain about my video presentation of the topic in artificial intelligence. My professor name is Jufei Yua. The topic is called one-shot imitation learning. So here is the next slide. Today is explaining about my topic. This agenda is nothing but my whole one-shot imitation process of agenda. Coming to the abstract introduction, related work, one-shot imitation learning, algorithm, architecture, experiment, conclusion. These are all the things. So here you go, the abstraction. So the abstraction is nothing but the one shot of learning algorithms is nothing but distinguish two images based on their similarities. Based on their similarities, the two images we can distinguish whether it is a correct image or else it's a blurred image like that. So with that image, we process the object of one shot, instruct the model to make its own references and about the similarity based fewest possible actions. So it is a variable arithmetical feature engineering, feasible number of samples and collecting the samples and using with the preferred robots to learn. Therefore, we want to without need any task specific things immediately to new the instance of a small number of demonstrations. So we analyze the case where we each task has very large, perhaps in instance. For example, one assignment could be arrange all the blocks in a table like that. So while another task assembling all the blocks on a table into two blocks towers. Example, uh, different tasks would be included in different sets of blocks, right? So in initial states, it's a one of kind of a scenario. So like that, I'm going to explain the introduction also. The introduction is nothing but the robotic system that can carry out variety of difficulty, right, situations in a useful job such as plants, houseworks, cooking, food, and the innovators and able to pick up the some of the human duties. So this is gonna be useful through using these robotics. Imagine the how necessary it is achieving this first and issues of detection. So pick up all these challenging objects and of position of arrange desirable configurations. We have the kind of issues. So first issue is the use of dexterity and must learn how to approach and grab the image of object and pick up the challenges objects and position to arrange where it is the exact thing to configure it. The second issue is to communicate how the convey purpose of the work to hand the robot and it can carry out the wider range of beginning circumstances. So these are the introduction part and the related work is nothing but the related work how we gonna do on that process. Using some skills throughout watching demonstration is considered as limitations and also which carries out supervised learning from observations into actions and inversing the reinforcement learning things. So even though this is a earlier research produced wide range also, outstanding robots findings it's like each other separately and mastering the next easier. For example, learning fast reinforcement learning agents, policies, generative modelings, and image recognitions. These all things comes under the related work only. So an issues arises for these classes to standard neural networks also it be done with the classification since there is any enough data or more updating retaining of under the situation may be expense or impossible. So here you go the one shot imitation learning exactly thing. These in one shot imitation learning things we can add the two more images to the camera input and passport size photo like that here to info the neural network access how similar they are to one on each other. It's a one kind of example I'm showing. This is the diagram where you can show the formula of encoding the formulas of using the distribution of a task is denoted by T. A specific task is denoted by T and distribution demonstration for the task denoted by the T. And also, observation and detectives make up to demonstrate as follows: D is equal to the fx1 and x2. These are the formulas we're supposed to, we can find the effective demonstration. We can find that effective demonstration for each every task. Although it is necessary doing training only, we assume that we task have some kind of social valued and function RTD, for instance, binary values also for the significant success. These are the performance we're gonna do in a one-shot limitation learning. And these are the algorithm, kind of algorithm what we used. It helps in image binding, I mean image limitation. So we implement or we imitation the learning things, cloning the and like a behavioral cloning and a dagger. Dagger is nothing but which means the demonstration of to define the kind of algorithm for the situation, how it evolves and shows the well-shaped reward function. In a wider coverage of trajectory spaces, we first gather some of the examples of assignment adding noise to the actions. We randomly select tasks from the list and replacement like that. The policy is trained for to regress the desired behaviors of a condition we are observed in the demonstration of based on the whether it is continuous or a discrete. We can find out that using these algorithms. So in algorithms, the formulation, what kind of formula we use in this kind of learn, we take the input as a task T and demonstration D. These are the formula and gives the input. So by the end of the output, how the action maximize the expected reward given by the presented state and also sequence learn policies of the functions of RTT. So in each training iteration, sample task is bit vague and list of tasks. For example, for each sample task, they demonstrate along with the small batch of observation action parts and step-by-step process. So these are the architecture of the image, imitation of the project, one shot. So these are the inputs, 2D agent position and 2D landmark locations. We are taking this push y and push x as simple objects. From that, it evaluating the one by one step of a desired landmark, how the cone and square and star marks showing. They are pushing into the travel different direct robot, I mean different directions. The robot directed to travel desired landmark by pushing X and Y. With the both, you will get the output as a X and Y landmarks. So these are the architecture of particle reaching, how the particle is reaching along with the to identify the demonstration. So architecture in a plain LSTM is a demonstration trajectory of LSTM with the attention are the inputs. LSTM is nothing but less terminal mannequin and they calculate the weight of demonstration landmarks before applying the test C. We have to applying the test before we calculate the all demonstration landmarks through the varies of x and y lengths. So enter the weight of landmarks and only using the demonstration final state with the current agent side. Final output action is an outcome. So how the action it comes through the end of the particle where it's reaching the particle from one part to one. These are the finded by the particle reaching of architecture. We can justify with the robots. So the architecture explain how it gonna be happen. So in a task A and task B, we are taking the stack blocks of towers of height, like many demonstrations we can take, and we can imitate with the learning algorithm of diagonal. These all the things. After that, we gonna give a policy of task A, some policies like action and abstraction like that. With that policies, it gives the environment is it added for the task A. This is seen as same as known as task B. Also, we have added many demonstrations and we give you the imitation learning algorithm policy for task B. Also, it added the actions and environment things. Um, as usual, same in another task, we can say we are gonna add the imitation learning method. We're gonna add one more learning algorithm as meta learning algorithm of taking many demonstrations of from task A and task B. Couple of we carrying the couple of demonstrations at a time. We're using that. meta learning algorithm with that policy of task A, B, and A. We can demonstrate for the task A and one shot iterator. These are the one shot imitation learning, training of one shot imitator, how the training goes on from the issue. You can see the example demo, how it is moved in the producted action. These all things. Neural networks we added. So observation of this demo 2 and the demo 2, how it corresponds from the both neural networks. So coming to the next slide, these are the experiments results particle reaching. After done the experiment, how it is going to be shows the graph of the particles. That means plain LSTM train and testing the plain LSTM with the attention of all training and testing the models of this thing. We're gonna show the number of landmarks, how it transfer from where from 10 to 100% where the landmarks it should be in a different graph projection. These are the hypotheses of overfitting occurs while learning from complete demonstration final state of performs better. So the experiment, how it will work is like, is our framework capable of generation to task that is never encountered before? We contrast the function of the different text architecture to provide answers to this question. So uses same architecture before, but we clone behavior for the policy, right? So for the dagger, you can see the dagger right here. The dagger is used to train the policy while the architecture from the proceeding section. And final state, instead of considering the full demonstration trajectory, the architecture bases its assumption the final state, the block stacking tasks finally to the additional information. And here is the snapshots of a final the architecture, how the snapshot of a trajectory, which includes the last frame of and the all visualization of graphics, visualization of the thing graphs and the demonstration trajectories. This assumes the segmentation of demonstration and which it gives unfair advantages compared to other condition strategies. So these are the results of the dagger and the BC final state snapshots. So we can see the task one as a dagger is compatible to the behavior cloning, how the graph evolution is showing from the number of stages, one, two, two, the stages, how it's showing the demos and the dagger and the BC snapshot. These are the different graph evolution. So here is BC in the red color and the demo. This is showing the evolution of how it decreases from 100% to this state. This is a perform training task. While the performing the training task, it shows these algorithms how it trained by the visualization, and the second visualization is perform a test task. So how the test task is gonna be happen. The decreasation of see how from the 100% to level. The all algorithm while testing is showing a little bit different. The same similarities difference between these two. You're gonna check it here from the dagger is compatible to a behavior cloning, but segmented snapshots are not compatible to the different behavior cloning. So it is totally superior to entire and during condition time, it is demonstrates the performance tasks. So here is the conclusion of this whole topic. The one-shot learning algorithm main benefit is it classifies the photos based on how the similar they are, the rather than by examining similar and the rather difference of the photos, and it find by through the robotics and the image encryption decryption like that things. So needed to the train model and greedy decreased as a result. One shot learning provides must promises for face recognition also. It's a best practice for the one shot learning exhibition doors and many identify into many manuscripts like that. So as time as goes on, the less the one-shot learn model and one-shot learning memory augmented neural networks also gonna be happening next stage and the future further days in advanced of deep learning. These all things will help with the neural network things, which is gonna be augmented reality and virtual reality like that. So the technology is constantly evolving. We know that, and the less one shot also one of the model. It can be useful for the memory augmented neural networks, and also virtual reality. These all things comes under this one shot learning algorithms and one shot imitations. So the next stage advance is deep learning is in a practical substitution. It can be useful for that also. So that's it from my end. Thank you. Signing off, Karthik. Thank you, everyone. Have a good one.